Okay, my name is Nelson Diaz. Here are my two co-authors. They are the people who measure the data that I will be showing at the end of this presentation. And I'll give you some motivation. I'll discuss a little bit what first-class procedures are. We'll discuss a little bit of about a small module that implements what I'm calling attached domain arrays. And then I'll briefly touch on my implementation of this Levenberg-Marquardt algorithm. And finally, I'll show you two simple applications of the algorithm with meteorological data. Okay, so Levenberg-Marquardt is basically a curve-fitting procedure that's quite popular. It's simple stuff. You have a bunch of data and you want to fit a particular curve. But it's very helpful in research. It's often used. I use it a lot. I guess that most people do. And there are a lot of existing implementations. The plotting program called GNU-plot has a very nice implementation. Numerical recipes has a well-known implementation with a few problems, it appears, which are discussed here in this link. There is an implementation in the GNU Scientific Library. There is a C-mean-pack implementation, and there is a Python implementation. So lots of implementation of this thing, not necessarily the same algorithm, but variations thereof. In all cases, and I'm just giving you two examples here, what you have to do is you have to call a function. It's called MRQmin in numerical recipes, and that function itself calls another function as an argument. So what you have here is the need to pass a function as an argument to another function. and this is pretty common among the implementations that use programming languages. But to my knowledge, there's no native Chapel implementation of Levenberg-Marquardt. It's not very simple to do. It's not like a linear regression. In all cases, it seems that you need to do that. You need a procedure that calls another procedure, and that other procedure has an array as an argument. This is the main difficulty with Chapel, because Chapel can only have procedures as arguments if they are first-class functions. So it would be desirable to do something like that in Chapel. In my case, basically because my workflow is in Chapel. So I wouldn't like to stop using Chapel and go to Python or whatever, or GNU-plot just for that. One of the reviewers mentioned, and I'd like to mention it here, that there seems to be another way to do that with finite state machines. I looked at it, I searched for it, and I didn't find anything. So I apologize for not being able to discuss this matter further. So what are first-class procedures? First-class procedures are objects that can be captured as values according to the documentation in Chapel. And these are things that a first-class procedure cannot be. These items here. And the one that's bottleneck in the case of the LM method is that a first-class procedure cannot be generic. And we'll see an example in the next slides. So here's an example. I apologize for the small print, but I needed to fit this into this slide. Here's an example of a procedure F that calls another procedure G, and that procedure G in turn has an array as an argument. And when I try to write this code and I try to compile it, the compiler tells me that the proc G is generic. And the reason why it's generic is that it accepts an array that's pretty general. This can be any array of any kind, of any dimensions, and it seems that the compiler just can't deal with that. And the way to fix it is to put that array inside a record. And that's not my idea. I'd like to give the credits. This is inspired by the Chapel documentation. When the documentation talks about this accessor, it's inspired by a Stack Overflow discussion on ragged arrays. And what you do is you put a domain here, and you declare an array over that domain. It's a one-dimensional domain in this case. And you just write an accessor that will make the variable act a little bit like an array. And when I do that, and I declare the argument to G as a VAC and the argument to F as a VAC, and I compile it, it runs nicely. So, and by the way, the code is just F just calls G, G just sums the elements of the array, and then F tells me if the sum is positive, 0, or negative. It's very simple code that it serves just as an example here. What I did to implement Levenberg-Marquardt was to write a slightly more complicated module, but yet still very simple, that declares two objects, a VAC for a 1D array and a mat for matrix for a 2D array. It has a size method. It has a limited reindex method. It overloads operations, arithmetic operations between real and VAC and mat. It doesn't overload arrays with VACs, for instance. It doesn't allow slicing, so it's pretty simple. But it did the job in the case of the Levenberg-Marquardt algorithm, which is here. It's based on a very good presentation and implementation that is in the references by a guy called Gavin from Duke, I think. And it uses a few other modules that I wrote myself that are definitely not optimized at all. They're very simple stuff, but they make it simple also to understand to myself what I did and how I adapted Gavin's implementation, which, by the way, is in MATLAB. So I'll just show you the interface. The interface is a procedure where you give the data, you give the observed data and the independent data in arrays X and Y, actually in a matrix in an array. You give weights to each point, optionally. You give a set of parameters that you want to fit in your function, and it returns you the standard errors of estimate, a covariance matrix for the parameters, and here is your function, your objective function that you have to give to the function as well, and an optional stop criterion. And when I do that, inside the procedure, I can deal interchangeably with vectors, with VACs and mats in arrays. For instance, this is the part that calculates the Jacobian, and I can mix VACs with an array of increments to calculate finite differences. When I go to slicing, I need to access the records fields, but by and large, it does the job. So very simple stuff, but it allows me to pass a function that has an array as an argument to another function, which is the real problem here. And I'll just finish, I hope I still have some time, showing two very simple applications. One is to calculate something called the downwelling atmospheric radiation. It's a radiation that comes in a range of wavelengths. Here are a few empirical equations that are used in meteorology to estimate this thing. We need 4 data points. We need solar radiation. We need the radiation at the top of the atmosphere. We need water vapor pressure, and we need air temperature. And with these 4 data points, we go through this formulae here, and at the end of the thing, you get the estimate of the downwelling atmospheric radiation. This thing requires 6 parameters, which I call A and B P, A and B B, and C and D B. Sorry for the spaghetti letters. And as you can see, it fits stuff pretty well if it's given a matrix of 725 days of measurement, with each day with these 4 independent variables, and you give it an array of measured data. So that's one example. The other example is to fit an albedo. The albedo is the ratio of the reflected over incoming radiation for that particular surface. This is a rice paddy, and the albedo changes along the year, as you can see. And here I fitted a polynomial to the 365 days of the year. X is the day of the year, and P0 through P4 are the parameters or the coefficients for this polynomial. So for the few tests that I ran, I'm showing you just two here. The thing works. It fits my needs. It's simple, and it circumvents one problem. Actually, the only one problem that I ever encountered with the language itself, something that the language could not do it off the shelf. So it's a simple solution. It's simple to create these VECs. They're very much like arrays. They are array-like. I cannot tell you about how efficient this thing is. It may not be the most efficient thing in the world, but this is a solution that made it possible to implement a rather popular method to fit functions and formula and find the best parameters for this. There's probably a lot of room for improvement in the attached domain array module and in LevMar. And I'll be happy to discuss the things if anybody is interested. And that's it. Thanks a lot for the attention. And if there are any questions, I'll be more than happy to discuss them.
Thank you so much for the presentation. That was an interesting topic. So is there any questions? So that's a time for you guys to ask any potential questions from Nelson.
I don't know that I have a question, but a comment, and I see Luca made the same comment in the chat. As you were talking, I was having this sense of deja vu, and I believe Luca ran into a very similar issue to this and was asking about on Gitter just either earlier this week or last week. It does feel as though this need to be able to have first-class procedures, or I think it also applies to exported procedures, which have to be non-generic to be able to accept array arguments. And so it feels like that's something, you know, when multiple people start hitting that in short order, and it has happened over years as well, to me it feels like something that it's probably time for us to address. If I understand correctly, if you could have simply used the first-class procedures with the arrays, you would not have had to create the VEC and MAC classes. Is that correct? Yeah. Okay.
Yeah. It's a fix. It's a small fix, but I'm more than happy with it because it's not too difficult to implement and it works, at least for these simple cases that I showed.
Yeah. Okay. I see other hands are up, so I'll get out of the way. But again, interesting timing of that that issue.
Okay.
Hi.
Yeah,
Oh,
go ahead, please.
Hi, thanks for the talk. I wanted to mention, kind of related to what Brad was bringing up, two things. One thing is, you know, eventually I would expect that we will have first-class functions that can be generic. The second thing is that you can actually use a different mechanism to pass some kind of function you want to run in another function. This pattern, I like to call it function object. It's actually using the same idea that you showed with the record where you had a this accessor. So you would make a record for the function and the this accessor would run the function. And then you can pass that to your the function that needed the first class argument as a generic thing. And I can write up an example and put it in the chat so that you have something more complete to go on.
Absolutely. I think I know what you're talking about, and that was my first solution.
Okay.
If we're talking about the same thing, the problem to me was that in this case, I needed some of these functions to be very generic. So I needed to leave f, the function, as a very generic thing, and I wouldn't declare it. I wouldn't declare the structure, the number of parameters, etc.
That's right.
So that gave me a little bit of discomfort. And when I found this solution that I presented, I felt a little bit happier in terms of specifying what I'm passing more thoroughly.
Yes, yes.
But absolutely, there are at least two other ways, I think, of doing the same thing with
Yes.
records as well. Yeah.
Okay,
Thanks.
very good. That's good to know that you knew about that one and you didn't like it because you wanted to be able to put like what is the type of the function in there. Thanks.